this new section of the course. Here we'll be looking at graphs and functions. Namely, first of all we will look at the modulus function and what it is. Then we'll look at functions and mappings. Then we'll look into composition of functions. Then we'll be finding how to calculate the inverse of a function. Then we'll look at graphs of modulus functions and combining graphs and transformations. And finally, we'll be solving some problems that involves modulus functions and graphs. Okay, as always, I encourage you to pause the video here, have a go at the prior knowledge test, and then play the video and check your answers with me. Okay, pause the video now and have a go. Right, I hope you've had a go at these questions by yourself. Making y the subject of the formula is absolutely essential, particularly when we have to find the inverse of a function. So, I'll do these first few questions by hand. If I have to make the y subject of this formula, first thing I would do is I swap 7y and 5x around. I'll take 7y to the left and I'll write 9 minus 5x. I would leave the negative sign where it is. Then I would simply divide by 7. Y will be equal to 1/7 times this bracket, 9 minus 5x. There's no need to multiply out the bracket, you could leave it as it is. First, I would multiply by 5, so I would get this expression. Then I would subtract 8x, y on the right, then I would have 5p take away 8x. Last step would be divide by 2, so y would be half multiplied by 5p minus 8x. We have y on the left and y on the right. You have to be careful in this kind of situations. We collect expressions or terms that have y's in them on one side of the equation. I would prefer to bring the negative 8y to the right. So that means I'm going to subtract 4 from both sides. I would simply write 5x, take away 4 on the left, and on the right I would have 9xy plus 8y. Okay, I'm gonna underline these y's here. Ultimately need to have one y on one side of the equation, so we'll factor it out. Factorizing y, we'll have 9x plus 8 in the bracket, and we'll leave 5x minus 4 as it is. Next step is to divide by this bracket, so I'll squeeze my answer on actually I'm going to put the answer here. Y will be 5x minus 4 all over 9x plus 8. Okay. So, in question 2a, you've been asked to simplify these expressions. Expanding the bracket and take away 4 will leave us with 25x squared. Multiply these two together and double them, I would have minus 30x. Then multiplying minus 3 by minus 3 will give us a 9, and taking away 4 from that will leave us with 25x squared minus 30x plus 5. This is the final answer for part A. This expression here will simplify to 6x minus 10 minus 4, which gives us minus 14. You might be able to factorize the denominator now. I would say this is the simplest form of that expression. For this fraction here, I noticed that 5 needs to be multiplied by x over 2. So we leave x plus 4 as it is, and we write 5 times x plus 2. That means that we'll have a common denominator on top of the fraction of x plus 2. The bottom also has a common denominator of x plus 2. So I'll leave x plus 4 as it is, and I'll write minus 3 multiplied by x plus 2. What you notice is that x plus 2 is repeated here and here. So we could cancel them out like so. We'll be left with 6x plus 14 on the top and minus 2x. 4 minus 6 is minus 2 at the bottom. We could factorize 2 out of the top and the bottom. With 3x plus 7 and factorizing a negative 2 at the bottom will leave us with x plus 1. We could cancel the 2's out, but the minus sign remains. Okay, so please pause the video. I'm going to rub these expressions off that are written in handwriting, and I'll have a go at the next questions. To deal with question 3, we have to sketch some graphs. Having done year 12, you should be familiar with these graphs, so I'm simply going to show them to you. This is an exponential function, and when you've been asked to sketch a graph, make sure you label any points where the graph crosses the x and y axis. Intersection points are essential, so 0 and 1 there is absolutely essential. Next question is the graph of a cubic curve. It will have a root at minus 4 and plus 5 and at 0, so make sure you label the roots clearly. Next question is a sine curve between 0 and 360 degrees. Make sure you label the intersection points clearly. This is not visible, that's a minus 4, this is 0, and that's a 5. 0 and 1. Alright, for question 4, you simply have to do a simple substitution into the equation there. So I'm just going to show you the answer there. Okay, please make sure you've had a go at these type of questions, and if you find any of these skills difficult, please find questions that involve those and practice as often as possible. I'll see you in the next video.